Hi, welcome to another video episode on my fischertechnik monorail with a propeller, which is right here, and as you may or may not know, controlled by the BeagleBoard running Linux, attached to an serial RS-232 cable and terminal on a laptop, fischertechnik robo interface, which then through the BeagleBoard controls this monorail. Last time I found that the timing of return from both sides was rather different. The side of the, well, what can I call it? The light side is completely different. It's 1 second, while the turnaround time at the sonar side, where it is now, takes 4 seconds. And this object here, I've tried last time to influence the turnaround time. That didn't matter at all. So with or without this, and let me remove this piece for now, turnaround time here and here, both for the is both some 4 seconds. Now I've been told that propellers have a different propelling force in one way and the other. So that explains only the speed that it goes one way or the other. It does not in any way, in my opinion, explain the turnaround time of 4 seconds. So that is what I want to focus on right now. And last time I tried to explain it for myself with the clock speed of this board, the BeagleBoard, which has some 750 megahertz. But this interface is of course in between. So the question is, how can that combination be of influence when the turnaround time on the light side is 1 and on the sonar side is 2 seconds? Other explanation is, what is the reaction time of the sonar? The sonar has, as I explained before, a minimum distance of 2 centimeters and a resolution of 1 centimeter, so within 1 centimeter range it won't measure. So what I want to do now is not letting the carriage just run free, but I'll let it run, hold it with my hand, and then check on the screen what the result is. I will be very curious. So let's go check out. So after this introduction, let's do some testing indeed, focusing on the sonar. So I'm starting the program. You may be able to hear the propeller. I'm holding it still, 10 centimeters. The question is it really 10 centimeters? Could be. So let's grab some kind of measurement. Well, this will have to do. It's derailed now, so let's put it at a certain distance. And the maximum distance is 7 centimeters till the end of this this measuring thing. Right now it says 11, which is not correct because it is to where is it 11? To the motor it is 8. And the power connector is 1 centimeter long, so that makes 6. And the carriage itself is 6 something, 7 something, no 6. So 10 doesn't make any sense at all. Taking it to some 2 centimeters, and the very strange thing is, as you see, I'm keeping it still at some 2 centimeters. Now 1 centimeter and 2 centimeters. One and 2. Again 1 and 2. So I don't, and it you see it changing direction. Now 1 again and 2 centimeters, and I'm talking physical distances. Again at 1, and this doesn't make sense at all. It says 4. Then again 2 centimeters distance, and it says 5 and 11. So what if I put it back at 7 and it says 8? Well, that is about moi, okay, acceptable. Bring it back to 2. Let's see when it gives some 2 centimeters. It doesn't. It says 5 and back to 11, 4. The only thing that is within measurable distance is the power connector now, and the motor is at 2 centimeters, which is minimum. So I'll let it go, but you see that there is something completely off. Really completely off. And I have no idea about the cause. So how is this possible? Yeah, I have to figure something out, I guess. So after this test, let's take a closer look at the construction of the carriage. Oops, I have to take care of that. And as you can see, the question is, what does it measure? What is measured? Is this measured? Or is this measured? This is 1 centimeter. So let me just hold the whole set up like this. This is about 2 centimeters, the minimum distance, but here you would think it doesn't even measure the motor, it measures something of the carriage. While from somewhere like here it will measure the motor. So in this perspective, it may be best to reconsider either the construction of the motor or the location, the height of the sonar. So that it actually measures the same thing. Because if you measure at this distance, either that or that is quite dirty data. So that's a good thing to think about. And I actually think I should lower the sonar. I think that's a nice idea. So let's do just that. I don't have to lower everything. But then again, this isn't completely fixed, so I would have to turn this around. And then see how this works out. So this would go like this and like this. Will this work? It has to work, yes, there it goes. Okay. So right now the sonar is how much lower? About 1 centimeter lower. And then I'll have to remove this wire, the sonar wire. So let's put this guide here. Alright. And let's see how that changes the behavior. Because if I once again hold it like this, now it focuses on what? The connectors, I think. Is it then advisable to put the connectors here? Probably, maybe, likely. Anyway, let's test this first and see what happens. I'm very curious. So once again I will hold the carriage by hand and see what happens this time. At some 7 centimeters, and it says 9, which means it is 2 centimeters off. Now I'm bringing it with my hand at 2 centimeters, so between sonar and the power connection, power connectors actually, is some 2 centimeters. It says 4. Now plus 1 centimeter. I noticed 3 and 4. Slightly away. Now it will be 5 centimeters. And it says 4 to 5 centimeters. Which is quite accurate. Or is it? Let's measure it by hand. Now the connectors are some 5 centimeters from the sonar. So not just the accuracy is 1 centimeter off. Let's say if it is 5 centimeters and I'm not holding it with my hand anymore, conclusion is now that no matter the distance, it is rounding the distance by 1 centimeter. So 2 maybe 1 and 3. 3 maybe 2 and 4. 2 and or 4. So if it measures 2, it can be 1.5, 2.5. And if it says 3, it may be 2.5 and 3.5. And so on and so on. Now it actually holds on 1 centimeter. No, 2 centimeters. The motor is at 2 centimeters. The power connector is at 1. And it says 3. But what is at 3 centimeters? That is the good question. Let's measure something. Let's see, this is, it's not 3 centimeters at all, more like 2.5. So that is rounding up. Now I'm touching it slightly and it goes, and it says 14, so 14 may be 13.5. So that is as far as the distance goes. How about the turnaround time of the propeller? Let's go measure that. 1, 2, 3. 1, 2. 1, 2, 3, 4. And that is at the side of the sonar. The 1 is at the side of the light. So despite the inaccuracy of the sonar, probably caused by latency as well, the turnaround time of the sonar of the propeller should be different. So that's something else to think of. But I do think that the adjustment of the height of the sonar was a good decision. I may even I should actually change the holes in the motor where the connectors are in, or otherwise said, put the connectors in the side connectors of the motor. Let's see what happens then. So to get it more accurate, I want to put these either up or in the side, and at this moment at the side up is not possible, so I have to put it in the side, and that gives a problem, because when I do it like this I have to stretch or pull this a little bit apart to have more loose wire. And right now that is a problem. So now I can do it. I can do it like that. So now the situation is like this. No more false readings in that perspective. So let's see how this works out. It can go closer, and it says 2. 14 and 2. Well, this is clearly no 2 centimeters. This is less than 1, but it says 2, so 2 and 13. So I think, since I didn't have the 13 value earlier, that the power connector was giving false data. And now it clearly says 2 each time, which is not very correct either, but it is the lowest value it can give. And now I see one problem here. Okay. So these are both improvements. Both the relocation of the sonar to set it lower and the relocation of the power connectors. Still, the turnaround time of the propeller, I don't like that, but I think the distance is more accurate now, so I like that part, and the other thing has to come next time. So for now, thank you for watching, and to be continued.